Hello and welcome back to the Math 0332 notes. I'm Mr. Lee. Let's pick up. Last time we dealt with fractions. Now we're dealing with mixed numbers, which will actually behave very similarly. So we mentioned it in an earlier video, but rational numbers that are things that can be written as a fraction. For example, any integers or whole numbers can be written as a fraction over 1. One interesting part of any rational number is that it can be written as a decimal that's either terminating or repeating. So for example, pi is not one of them, but any fraction can be written as a decimal with a terminating or repeating decimal. Improper fractions are a special type of fraction where the numerator is larger than the denominator, which means they're bigger than 1 and they have a tendency to be able to be converted into mixed numbers. Mixed numbers are kind of useful, particularly in things like cooking, where if you're scaling a recipe, you may end up with like 27 cups of flour. Well, that's not always that useful because your measurement comes in whole cups. So if you convert it to a mixed number, that's 2 6/7. It gives you a better understanding of exactly how much you need to add. So when you're converting mixed numbers to improper fractions, you multiply the denominator of the fraction by the whole number, and then add the numerator, and then you leave it all over the denominator. Now another way to think of this is 6 2/3 is really 6 plus 2/3, or 6 over 1 plus 2 over 3. In order to get a common denominator between 1 and any other number is that other number, which means to turn that 1 into the 3 in this case, I have to multiply both numerator and denominator by 3. So we get 18 over 3 plus 2 over 3. This ends up at 20 over 3. Again, to get this numerator, one not really cheap, but one trick people recognize is you take your denominator 3, you multiply it by the number in front 6, and then you add 2. What's up here by itself. It's kind of a shorthand way of doing that because 18 plus 2 is 20, and you just leave it over the denominator of the fraction. So you'll see that no matter which way you do this, you'll get the same answer. So let's try this again with -7 1/5. Now, if there's a negative in front of the whole thing, that's like negative in parentheses 7 plus 1/5. Both parts, if you distribute, will end up being negative. So what I like to do with negative mixed numbers is just convert them and throw the negative back on there when I'm done. By the same argument that we used here, the shortcut here is 5 times 7 plus 1, and it should stay over our denominator. Now 5 times 7 is 35, plus 1 is 36. Now because the original thing was negative, we can say this is really negative 36 over 5. That gives us our answer. And 3 and 4 are very similar, and I will leave them for you to try yourself. Now, if you can go from a mixed number to an improper fraction, you should also be able to go from an improper fraction back to a mixed number. To do this, you kind of have to break out your old school division. You need to be able to divide your denominator into your numerator. That means if you have 15 divided by 4, you're like, well, how many times does 5 go into 14? 5 goes into 1 0 times, but 5 goes into 4 twice. 2 times 5 is 10, so we'll subtract off the 10 to get a remainder of 4. The number up here is your whole number. The remainder is the one that goes over whatever you were dividing by, so 14/5 is really 2 4/5 when you do your division. Similarly, when I'm doing negative numbers, what I like to do is just save the negative for the end and just divide. Let's do number 3. I can leave number 2 for you to try. -32 11ths into a mixed number. So how many times does 11 go into 32? 11 goes into 3 0 times. 11 into 32 only goes in twice. 2 times 11 is 22. Since we've now accounted for it, we subtract it off, and we get 10. So in this case, that means my remainder is 10, which will sit over our 11. I've got 2 and 10 elevenths. Then, and because it started negative, it will continue to be negative. So again, 4 is kind of similar, so I would practice that. If it's going to reduce, it'll be clear in the fraction that it reduces, so you don't have to worry about reducing before doing this. You can just do it. Now, there's also operations between mixed numbers, but it's actually very similar to your operations between fractions with maybe 1 or 2 exceptions. You're first going to convert it to a fraction, so you can do all the same things you did with your fractions, and then once you get an answer, you're going to convert it back to a mixed number. So what do I mean by that? Well, let's look at 6 2/3 times 4 1/5. If I convert this to a mixed number, or into an improper fraction, 3 times 6 is 18, plus 2 is 20. This is 20 over 3. And we also did this exact one, I think, on the last page, or the page before that. 4 1/5. 5 times 4 plus 1 over 5 is 21 over 5. So we get 20 over 3 times 21 over 5. From here, what we can do is, again, we know how to multiply fractions. It's multiply across. So this ends up being 420 over 15. Now we could probably look at this and recognize that both of these are multiples of 5. However, we also can just do 15 into 420. 15 goes into 4, no times, but 15 goes into 42 twice, because 15 times 2 is 30. Subtract it off, you get 12, and bring down the 0. And actually, amazingly, 15 goes into 120 8 times, because 8 times 15 is exactly 120, and it leaves you with a remainder of 0. So 420 over 15 is correct, but we know that when we do 420 divided by 15, we actually get 28. Dividing mixed numbers is very similar to dividing fractions. Again, just like this one, you'll convert them both to improper fractions. Then you'll use your keep, change, flip, so that your division turns into multiplication, and then you'll clean up from there. Let's talk about, though, adding or subtracting these fractions. Let's go ahead and do number 4, the subtraction. Same thing, you want to convert it to a mixed number, so 7 times 3 is 21, plus 4 is 25, so 25 over 7. For the 2 4/5, 5 times 2 plus 4 over 5 is 10, 14 over 5. So we have 25 sevenths minus 14 fifths. Unfortunately, these two do not have the same denominator, so we need to get a common denominator. The good news is that they're both prime, so your common denominator, you just need to take the two numbers and multiply them. So 7 times 5 is 35. To turn the 7 into a 35, we'll multiply by 5. To turn the 5 into a 35, it's missing the 7, so we'll multiply by 7. So this ends up being 125 over 35 minus 98 over 35. Once we've done that, we know that when we add or subtract fractions, we just add or subtract across the numerator. So this is 125 minus 98, all divided by 35, which is 27 over 35. We could check for factors. However, I know 27 is 3 times 3 times 3, and we know that the 35 is 7 times 5. So we're kind of aware now that that's not going to reduce. Furthermore, because this fraction isn't improper, because the numerator is not bigger than the denominator, it doesn't even need to be converted to a mixed number because this is a proper fraction. So it's like you have 0 and 27 35ths. All of our proper fractions really have a whole number of 0. But 2 and 3 are similar that you can work out yourself, but really it works similar to fractions so long as you can convert and you know your operations with fractions. Operations with mixed numbers just kind of follow suit. And that is all for this video.